Let's learn about another interesting concept of array broadcasting. Broadcasting means we are going to perform the same operation on each of the elements of the array. So let us suppose I am given this array ARR1 having 6 elements and I want to add 10 to each of these elements, then I can perform array broadcasting. So in this case I am going to pass the name of the array, which is ARR1, to the print function. Then I will put a plus sign and then pass a scalar value 10, and when I'll run this cell, this 10 will be added to each of the elements of the array. In this way, you can perform any operation for each of the elements, and this is known as array broadcasting. Moving on, NumPy arrays also support reshaping. Reshaping allows you to change the shape of an array without changing the data. Let us suppose that I want to reshape this one-dimensional array into a 2D matrix having 3 rows and 2 columns. So in order to reshape it, I will just copy the elements here and let's rename the array as ARR2. I will type the same elements and at the end of this line, I will put dot reshape, which is an existing method, and after that I will supply the number of rows and columns. So I need 3 rows and 2 columns, and after that I will print this array 2, and when I'll run the cell, you will notice 3 rows having 2 columns each. Similarly, if I want, I can change it into 2 rows and 3 columns also. Just make sure that the number of elements in your 1D array should be an even number, or for example, if you have 5 elements, then you can either shape it as 1 by 5, that means 1 row and 5 columns, or 5 rows and 1 column. So the proper division of elements is in your hands, but here we have 6 elements, so it can be divided into 6 by 1 or 1 by 6, 2 by 3 or 3 by 2. So this is how you reshape an existing one-dimensional array into a 2D array or matrix. On the other hand, if I want to reshape an existing matrix into a flat array or a 1D array, then I can use the flatten method. Let me show you how it will be done. So in this case, I will convert this matrix back into a 1D array. For that, I will type here ARR2 dot flatten, and this flatten method will regenerate the 1D array, as you can see over here. Next, I want to discuss about concatenation and splitting of arrays. So let us suppose I am taking the same array ARR1 and I want to split this array into 3 sub-arrays, each having 2 elements. So I can use the split method to split this array. Let's first give the name to the sub-arrays. Let's say A, B and C are the sub-arrays. After that, I will type np.split. Then I will pass the name of the array that I am going to split and into how many arrays I am splitting it. It's 3. And after this, I can print each of the sub-arrays one by one. So let us suppose I am printing array A. So when I'll run this cell, I get 1, 2. That means the first 2 elements are in array A. Similarly, if you print B and then print C, you will notice that all the elements have been equally split, equally divided into these 3 arrays. Just as we can divide a single array into sub-arrays, we can also combine the sub-arrays into a single array, and this method is known as concatenation. So let us suppose I want to combine sub-arrays A and B and create a new array, let's say ARR3. So I will use concatenate method. Let me show you how it will be done. So first of all, the name of the array is ARR3. After that, I will type np.concatenate, and then inside the parenthesis, I will pass the pair that I am combining. So I am combining A with B. So here, if I print ARR3 and run the cell, so I get to see a concatenated array here. If you found this video helpful, then don't forget to share it with your friends. Also, like and comment on this video and subscribe my channel Programming Horizons for more videos like this.